everyone, this is Mr. Zikri speaking. Today we are going to do exercise on RLC circuit. Actually, this is already given to you in the class and then you already have done it on your book. Today we are going to solve the problem given. So here we have a question from UAN 2004 number 31. An RL circuit is connected in series connection with AC source 100 volt. Look at the picture. The number that is shown by the voltmeter and ammeter is 80 volt and 2 amperes. What is the inductive reactance? So here the potential difference across R is given 80 volt, and then the current flowing in the circuit is 2 ampere, and here the AC source V is given 100 volt. So from here we can find VL first, and then afterward we are going to find XL, that is being asked, inductive reactance. So first of all, because we know V actually the result of VR squared added by VL mean VC squared. We doesn't have VC here, that means we doesn't have capacitor in the circuit, so this one is 0. So the V itself is 100, VR is 80 squared added by VL squared. From here it is actually a triple Pythagoras. So we are going to have VL actually 180, this one should be 60 volt. Because we know VL actually I times XL, we are going to find XL by dividing VL by I. VL itself is 60 and I, the current, is 2 ampere. So the XL, can get it, 30 ohm. Okay, now the second question. Please look at the figure below. V1 is resistor, voltage across resistor, and V2 voltage across inductor, and V3 actually the source voltage. Here it is given V2 and V3. Yeah. So it is being asked, what is the impedance? Impedance is Z. So first of all, we have to find V1, because we know that V3 equal to V1 squared added by V2 squared. Yeah. V3 it is given 10, V1 we don't know yet, and V2 is 8 squared. So this is also a triple Pythagoras theorem. This one is 10, 8, so this V1 is 6 volt. So as we know that the impedance, yeah, impedance, we have to find first the current. Yeah, the current can be gotten by finding V1 equal to IR. V1 itself is 6, I we don't know, and R is 30, so I is actually 0.2 ampere. And then let's find XL. XL is V2 over I. V2 itself is 8 over 0.2. So XL here, a minute, I'm going to move this. So XL is 80 over 2. So XL itself is 40 ohm. So we have XL and we have R. So Z actually, R squared added by XL XC squared. Well, we don't have XC here, so Z actually equal to 30 squared added by 50 squared. We have 50 ohm. Now, for the next question, in the circuit, there is R connected to inductor and connected to AC source. The current is 2 ampere. If the vector diagram below showing that tangen alpha is 3 over 4, 3/4, what is the voltage of inductor? So from here, we know that tangen alpha equal to 3 over 4. Tangen alpha is actually XL over R, 3 over 4. So XL over 60 equal to 3 over 4. So XL actually 360 over 4. So this one is 50. So XL itself is 55 ohm. So from here, we are going to find what is the voltage of inductor. Voltage of inductor is actually I times XL. I here given 2 amperes times 45 equal to 90 volt. Sorry for the bell. So going back to the question here, so the answer is 90 volt. Sorry, back again, we haven't, okay. So there are 3 more questions. Now for the next question here, a series connection having a resistor of 200 ohm and inductance of 0.8 Henry and capacitor with a capacitance of 8 microfarad, and is connected to 200 volt, and then angular frequency of 500 radian per second. What is the current inside that circuit? So we have R 200 ohm, and we have L 0.8 Henry, and then we have C 8 times 10 to the power of minus 6 Farad, and then voltage 200 volt, and omega 500 radian per second. What is the current? Yeah. First of all, we have to find XL. This is the first one. XC, second one, Z, then the last one is I. So let's find it one by one. As we know before, to find XL, we only need to multiply omega by L. Omega itself is 500, and then L given 0.8, so it is 40 ohm. Yeah. For 400 ohm, I'm sorry. And then XC is 1 over omega C. So here is given XC 500 times 8 times 10 to the power of minus 6. So XC actually 1 million over 4,000. Yeah. So we can cancel this. So 1,000 over 4, 250. So let's find Z. R squared headed by XL mean XC squared. R is given here 200 squared added by XL 400 minus 250 squared. So it is 200 squared added by 150 squared. This is triple Pythagoras. We know the answer is 250 ohm Z. So from here we can find I easily by dividing V over Z. V itself is here 200 over 250. So the answer is 0.8 ampere. Here. Next, we have RLC circuit. It is connected with a source with angular frequency of 2500 radian per second, and then it is connected to resistor 600 ohm and inductor 0.5 Henry and capacitor 0.4 times 10 to the power of minus 6 Farad. What is impedance of the circuit? So it is being asked Z. So I have to find XL, omega times L, omega 2500 times L 0.5, 1250 ohm, and XC 1 over omega C 1 over 2500 times 0.4 times 10 to the power minus 6. So here is actually 1 million over 1,000. So we can cancel this. So XZ is actually 1,000 ohm. So here Z actually the square root of 600 squared added by 1050 minus 1000 squared. So 600 squared added by 250 squared. So we have this. Okay, and the last question. The last question from the picture here, this is actually Vmax. Yeah? Vmax. So Vmax, yeah, is given actually 200 volt. So V effective actually equal to Vmax over square root of 2. Vmax 200 over square root of 2 times square root of 2 times square root of 2, we get 100 times square root of 2 volt. So that's all. Don't forget to comment, share, like, subscribe, and see you next time. Bye bye.